So good evening. I do apologize. I know I said 10 minutes, but I had connection issues, and then the interaction I had went slightly over time. So sorry, I'm 4 minutes late. Now, I'm just going to share my screen here, but I just wanted to start off by reminding us that I think tomorrow Abel is giving a talk at 17 hours. So our interaction tomorrow begins much earlier, right? So I'm just going to just switch to our calendar here, just so we there are a couple of things lined up here. So tomorrow or something, yes. So we have Abel who's giving a talk, and then we immediately transition and continue our interaction. Now, this was tagged as being evaluation, but you notice that we covered 7.2 yesterday, and so we're covering evaluation today. The plan tomorrow is to see if we can, after Abel's talk, to see if we can play around with an information retrieval platform to have a feel of exactly how it works, putting to practice some of these things that we are talking about here. So we'll see how it works out. So in an ideal case, I think what would have been appropriate is to install one of these open source and freely available information retrieval platforms like either Apache Solar or Lucene, for instance. But I don't know. What we can do is try and see if we can. I mean, I can show you how to install this, and it's not that hard to install Apache Solar, right? It's like any other normal application anyway. But I think what's important is to actually get to understand exactly how it works, right? Which is why I'm suggesting that the focus, once we look at, I think someone wants to get in and I have to allow them in, right? Which is why the focus is really going to be more about using Apache Solar so that we see exactly how it works, right? And in fact, if you have bothered to go through the nodes, for instance, the part that has the component associated with there we go. The part that's associated with a practical component, you'll notice that besides the installation part is actually a substantial chunk dedicated to just trying to understand the output associated with Apache Solar, right? So we want to be able to really have a feel of how we get to interpret this sort of output. I mean, we don't have to, but it will help us reinforce some of these things we're talking about, right? So things like query time, for instance, right? And you know, the list of documents that are going to be returned, for instance. And what you will notice once we go through the practical components tomorrow is that, in fact, some of the things that were introduced during our discussion of markup languages will manifest themselves to a certain extent, because when you're interacting with Apache Solar, for instance, the output that you get is, by default, it's encoded using JSON, but you can tweak the output so that it's represented in XML format, for instance, right? So we'll see if, I'm not sure if the installation part is going to be that useful, but I think the most important part, in my opinion, the crucial part is being able to play around with Apache Solar like so, right? Like Apache Solar or something, I don't know. Right? So you play around with this and then try and run queries on Apache Solar itself. And what you will soon realize is that running queries using Apache Solar directly is no different from running queries from the application itself. So this Apache Solar instance that I'm accessing right now is the one that the DSpace application interacts with, right? Anyway, so again, back to the the schedule. So tomorrow we have a talk by Abel, and then we'll try and see if we have a practical interaction. And then on Monday, I know that the 8 was placed on Wednesday, but what I'm suggesting is that because Dr. Akandelo you told me that Dr. Akandelo had suggested that we perhaps try and see if we can wrap up our interactions in 5310 so that he starts interacting with you next week. And so what I'm proposing we do is we move module 8 to Monday so that immediately after Dokowe's talk, we transition and have our discussion of module number 8. In which case I should probably just move it to Monday, actually, so that we wrap up on Monday. And then we can schedule ad hoc interactions to try and see if there are specific areas that people would want us to discuss after you have the time to really read up on some of these things that we've been discussing. Direction has changed. Please take note. Yeah, so that's that about the interactions. I was tempted to see if we can move the module 8 over the weekend, but I figured maybe we'll give you an opportunity to synthesize the information retrieval component before we transition to module number 8. All right. So unless if there are any specific questions with regards to some of the things we discussed yesterday, I would like for us to proceed and just briefly look at how we go about evaluating information retrieval platforms. So what sort of aspects we tend to look at, essentially. I don't know if there are any questions with regards to what we looked at yesterday, which was 7.1 and 7.2. So in terms of 7.3, essentially we're going to discuss evaluation of information retrieval systems, and our focus is going to be on key evaluation aspects that are associated with information retrieval platforms, specific metrics or measurables that you tend to take into account when you decide on which evaluation aspect you want to focus on. And really, specifically in terms of aspects, you notice that our focus is going to be on efficiency and effectiveness. Right? So we'll further drill down and try and understand what efficiency and effectiveness is all about. And during our discussion, I would like to encourage us to think about what we're going to be talking about from the perspective of the many applications that we use at work, for instance. So it could be Koha. If you have a DSpace instance, it could be a DSpace instance. If you play around with OPAT, maybe it could be OPAT, right? Because in all these different instances, what you're doing behind the scenes is when you're searching for content, you're interacting with an information retrieval system or platform. Although the gory details of what goes on behind are masked, right? Because what you do is you don't directly interact with information retrieval platform, but rather you interact with it via that nice end user interface that is usually aesthetically pleasing. So there will be features, right? Portions in that application where maybe there will be a search box, right? It could be a faceted search where there are different buttons that you tend to click to order results in a certain way. In certain instances, you have access to browse features, right? Which help complement whatever it is you're searching for. So I'd like to encourage us to think about what we're discussing from the perspective of these different broad range of applications that you use that way. And irrespective of which application you use, there's almost always searching and browsing involved. Right? Okay. So I'm not sure if we've gotten to a stage in 5010 where we've discussed evaluation, right? It turns out that this is something that we do as part of the research process, actually, right? You have to evaluate, there's an evaluation, then you have results and discussion, right? So evaluation is nothing more than a systematic process of trying to determine the merit or worth of something, right? And the process of determining the merit or worth of something is done relative to a predefined criteria, right? So, sorry, I'm waffling around because I think there's someone who wants to get into the meeting here. And where are they? They're here. Right, so you conduct an evaluation, and this is broadly speaking, you conduct an evaluation to determine the relative worth of something. So hopefully when you bought, if you have a vehicle like a Corolla, hopefully you evaluated the Corolla relative to something else, on the of fuel consumption, speed, right? Maximum speed, top speed, if you're one of those who is obsessed with fast cars, for instance. Durability, right? So ideally, you typically have a specified criteria against which you determine an item's relative worth and importance. And the reason you do this is you ultimately want to make a decision on whether to gauge whether or not something is better than maybe an alternative, right? Or to determine whether or not it makes sense for you to go for that particular subject that you're evaluating. Right. A key thing of evaluation is that it has to be, especially when it comes to science and research, is it has to be systematic and rigorous. Right. So you have to make sure that the process, evaluation process you're undergoing, conforms to certain strict requirements, like the process being reproducible, right? So if you undertake an evaluation process, it should be possible for somebody else to be able to get results that are similar or at least closer to the sort of results that you got, right? And the only way you can do that is if the evaluation process is systematic and very thorough or rigorous. Right, which is why whenever before you conduct an evaluation, I say when it comes to research, so say, can you outline the study design? Part of the reason you're doing that is for future reference, so that if somebody else comes and reads up your work or looks at the process you are going through to evaluate this, they'll be repeating your steps with the hope that they'll get similar results or exact results. Right, so again, evaluation obviously involves a critical assessment given this set of objectives that conform to the specified criteria. Evaluation 101, I suppose. And ideally, I mean, for the purposes of 5310 here, we want to ensure that it conforms to the scientific method or to research, right? Make sure that it's reproducible, it's understandable. The evaluation strategy must use sufficient observations, right? So this idea of ensuring that there's some aspect of statistical significance, for instance, if you're working with a data set that would need to be verified against some statistical method, this is something that you need to take into account. And you soon, I don't know if I'll make mention of this, but you realize that for certain evaluation metrics, it becomes important that you evaluate the statistical significance, or that you ascertain the statistical significance of your results, right? In aspects such as efficiency, that might not really be that important, because essentially what you're doing is benchmarking results against computing resources. All right, so the normal statistical tests that have been introduced to us in 5010 will apply, right? And we know that whether or not you're going to use chi-square, or whether or not you're going to use a t-test, for instance, would be dependent on the format of the data that you're working with, essentially. But just to mention here that it may be important that you perform statistical tests. And you will soon see that for effectiveness, when evaluating the effectiveness, this becomes important, because evaluation of the effectiveness or efficacy of an information retrieval platform is for the most part subjective. Because it's subjective, you need to ensure that you have sufficient observations. because this idea of sufficient observations is important, you want to ensure that you are working with the right number of observations. You want to ensure that you prove that the results you're getting are not by chance, right? Which is why you're performing these statistical tests, essentially. So it's usually the case that that information retrieval platforms are evaluated against pre-existing data sets. These are called test-based, right? And so if you look up things like, if you look up Trek, for instance, there are these data sets that people constantly produce, right? So the idea behind these predefined test-based or data sets is that there are already results that have been benchmarked. And so what you're doing is trying to see how well your information retrieval platform performs relative to the pre-existing tests. If you don't use these predefined, if you don't use these pre-existing data sets, you'd have to create your own data sets from scratch. And this is a time-consuming task, by the way. It's involving. It's not that easy. Somebody wants to come in. I'll have to pause here. I apologize for the waffling around. And the idea behind using these pre-existing test bases, you have access to things like predefined queries, for instance, right? So what you typically do when you're evaluating this information retrieval platform is you would perhaps, this is just hypothetical here, you tell a user to say, use this query, run it against this information retrieval platform, and tell us whether the results that you get back are relevant to your search, right? So you do not, you'd have the users use a predefined query because what you're doing is what was introduced to us in 5010. You are taking into account control variables, right? Factors that might influence the overall results of the evaluation process. And it turns out that for IR evaluation, one of those factors is the query. If I tell you to say, search for information about digital libraries right now, oh, maybe we should do this. Can I ask that we quickly do a simple exercise here? I want to prove something. Can I ask that what sort of query would you type in Google if you were asked to search for information about let's see, about just self-archiving in institutional repositories? What sort of query would you, well, if you're given a scenario to say, can you use Google to find out if self-archiving, the extent to which self-archiving has been done in institutions of higher learning in Africa? What sort of queries would you type? I just want to see. Can you type in the query to that sort of scenario? I don't know if you can get what I mean here. I want to do an exercise here. Just any random query that you feed out in Google, can you type into the chat box? Nobody wants to type. I don't know what that means, but am I making sense? I don't know if people can hear me, but given a scenario where you're asked to find out information using a search engine, information about whether, information about the extent to which self-archiving has been implemented in Africa, for instance, what sort of query would you type into Google to find information about that? Could you just type in the search box? There we go, okay. One query, there we go. More queries, please. Now, what you immediately notice here is that people are typing in different queries. I'm wondering why people don't want to participate about this. And so what I'm saying is that as part of the evaluation process, you want to control for this because this would affect the results, right? So the way you control for this is you give users predefined queries. Instead of leaving it open-ended, you tell them to say, copy this query and type it into the search platform, right? So which is why these test beds will typically have these predefined queries. And in fact, results associated with the relevant judgments will actually also be provided to you. And there are also tools that are normally provided for this. Right. So in terms of the evaluation aspects, there are various ways of looking at this. So some aspects can be implicit, can involve implicit or explicit metrics, right? So examples would be once a user, for instance, if you're evaluating an information retrieval platform, once a user types in a query and they hit the search button, how much time do they spend on that search engine result page, right? Do they spend a significant amount of time trying to find what they're looking for, or do they spend less time there, right? How many times do they get to click on the different results that are returned, right? So all of these things would be metrics that would be taken into account. And you notice that some of the metrics are implicit, some of them are explicit. Some evaluation aspects will involve subjective responses that are provided by users, right? So you would ask users that are recruited to participate in your evaluation to say, can you tell us that when you type in this query, can you tell us whether the results that are returned are related to the scenario that you've been given, right? So some users might say yes, some users might say no, in which case, I mean, that's subjective because there's no correct answer, right? Subjective judgments, by the way, typically would not involve binary responses, but it would be like a Likert scale that would be used. So you're asked, are the results relevant? To what extent are the results relevant? Strongly relevant, relevant, neutral, not relevant. I guess I don't know if there's anything like not strongly relevant, right? So that would be like you're getting subjective judgments, and then the idea is that if you combine those subjective judgments coming through from the different participants perceive the IR, right? Which is why we're saying it's subjective. In certain instances, that aspect might involve relevance feedback, and we discussed relevance feedback yesterday, right? Where you typically be wanting to figure out whether or not results that come back will satisfy a user's information need. In terms of the specific measurables that you tend to work with when you're evaluating IR platforms, the obvious ones obviously is like relevance, right? So there are predefined ways of ascertaining whether or not a search engine, an information retrieval platform, will be able to return relevant results once a user issues a certain query, right? So the metric there would be relevance, right? Whether or not the information retrieval is useful. These are all metrics. How much effort the user has to put in before they get the results they want, right? So could it be that when I search for, if I search for information on the Google, let's say information science, or I guess information retrieval. This is interesting. What about information retrieval in Africa? I wonder if there's any such thing as information retrieval in Africa. When I start sieving through the search engine result page in this case, do I need effort trying to find what I want? In other words, do I find myself figuring out that, oh, the first page does not have what I want? Maybe I'll check the second page. I discover that the second page also doesn't have what I want. I continue searching the third page. You notice that in all these different instances, the amount of effort that I'm putting in to find what I'm looking for is more, right? I'm spending more time doing this. So this is a metric as well. the completeness of the results, right? So is it the case that when I issue a query, for instance, an information retrieval platform, it gives me everything that I want? Or does it give me part of what I'm looking for, right? So completeness of results. And if you actually think about it, all these different aspects here can be clustered into two broad groups: effectiveness and efficiency. And fundamentally, really, this is what you do when you're evaluating information retrieval platforms or systems. You are measuring how well the platform performs relative to a predefined criteria, how successful it is at giving you what you want, or how fast it's able to give you what you want. So do you have to wait several seconds before you get back what you want, for instance? That would be efficiency. Does the information retrieval platform get to use a lot of RAM, for instance? That would be efficiency, computing resources. Is it that the index that you tend to generate once you, I guess, you index data is significantly larger? It occupies a lot of space. That would be computing resources as well, efficiency, right? Right. So broadly speaking, it's efficiency and effectiveness. And the effectiveness is nothing more than the extent towards which the IR platform conforms to the user's information need. Efficiency is related to the relative cost associated with the IR platform. And the relative cost here is not in monetary terms, but in terms of computing resources. So things like RAM, you find this response time in so many different information retrieval platforms. Right? On Google, one of the things, when you search in Google, one of the things that you have access to is how long it took for your query to be processed once you issue a search in that text box. Observe, if I come back here, you always have this number here. You have this in Bing as well, I hope. I haven't used Bing in a long time. But if I go to Bing and then I issue the same query, information retrieval in Africa, you will notice that one of the things that will be spit out for me, oh, this is not there. Bing, unfortunately, doesn't tell us how fast this query was executed, right, which is unfortunate. But the response time is usually a big one, right? And it's actually a metric that you'd probably have to pay particular attention to if you're thinking of implementing an information retrieval platform at a workplace, for instance. The last thing you'd want is for users to wait maybe 5 minutes for them to get back the result that they want. Right, so some examples here of these different aspects relative to, let's say, our DSpace instance at UNZA, for instance. Efficiency would involve things like how fast are we able to index a digital object once we deposit it into the repository? How quickly are users able to receive the feedback once they search for something in the repository? Right? That's all efficiency. Effectiveness for the DSpace instance is to what extent the DSpace instance is able to return results that are relevant to search queries that a user would type in. Right, so I hope this example kind of like helps put things into perspective, this idea of efficiency and effectiveness. Effectiveness is linked to the success of the IR relative to the information need. Efficiency is linked to computing resources and time associated with the IR platform itself. Efficiency is objective. Effectiveness is almost always subjective. Efficiency will rarely involve human subjects. Effectiveness will almost always involve human subjects because it is subjective. These are subjective measures that you're talking about. But obviously, I mean, when you're evaluating an IR platform, obviously, the first thing you do is you typically evaluate its efficiency, right? How quickly is it able to do things? How much RAM does it need? You know, is it able to handle a workload of, let's say, 1,000 users, for instance? But just measuring the efficiency itself is not enough, right? You typically need to involve users, because ultimately, once you deploy this IR platform, end users are the ones that are going to be interacting with it, either directly or indirectly using an end user application. And so you typically have to complement efficiency with effectiveness. The beauty with efficiency really is, like I said, is you're dealing with a machine, so most of these things can be automated. Like if you want to determine the index time, all you have to do is just put together some scripts and just time, right? And common strategies would involve you incrementally, you're increasing the number of documents that you're indexing, for instance, to try and figure out how much time is involved when you're indexing 10 documents, 100 documents, 1,000 documents, 10,000 documents, right? You're benchmarking the IR that way. So other specific metrics associated with efficiency would be the throughput of the indexing process, right? And this is nothing more than a measure of, let's say, the number of documents that you'd have indexed relative to the unit time. So it would be metrics like, oh, I'm able to index, given, let's say, a huge corpus of documents, we can come up with a value like we can index 10 documents per second or 20 documents per second. That would be the throughput, right? So the number of documents in this case that you are able to index in a given unit of time would be the throughput. Other metrics that you take into account is the total index that is generated, right? This is relative to how much space would be occupied on the computer where the information retrieval platform is deployed or is running from. Some additional metrics associated with efficiency here is the latency. So the time between when you issue the query and when you get back the result. That 0.62, the 0.70 you typically see on Google, for instance. That would be the latency. The throughput associated with the query would be the number of queries. You notice that the throughput associated with the query is the same as the indexing throughput. It's the number of queries processed in a given unit time. Right? This is not comprehensive, but it gives you an idea of the sort of measures that you take into account when you're evaluating the efficiency of IR platforms. What you perhaps have already figured out is that some of these, most resources that you have, the indexing time for a machine that has, more RAM will be much faster. If I was to benchmark how long it takes to index, let's say, 100 documents on a machine with 2 GB RAM and compare it against a machine with 11 GB RAM, you discover that a machine that has more RAM will be able to index those documents at a much faster rate. Right? So when you're conducting this evaluation strategy, this is the reason why it's important for you to take into account all the different confounding factors, control factors, right? So that the entire process is rigorous. And you want it to be rigorous so that the next person who would be interested in replicating what you did gets results that are somewhat closer or exactly the same as your result. Now, results will not be exactly the same because different versions of software might be used. For instance, the type of services that would be running on a particular computer might be different now in comparison to when the other person might be interested in replicating what you did. But the idea is to get something that's closer. It's not always exact, but closer. Which is, by the way, the reason why typically for efficiency evaluation, you get n-run averages. So in your benchmarking, let's say you are computing the index time, you repeat the process maybe 3 times or 5 times and then get the average. Because in all these different 3 times that you're running you're assessing the time it takes, what you will discover is that you get different times, right? So the idea is to get the average of the multiple runs. Just to put things into perspective here, examples here, what the screenshot is doing is it's showcasing, this would be the query time, I guess, if you look at this value here. No, actually, this is the indexing time here. So this example, this screenshot was I see it's indexing because I see the post requests here. This is indexing. I think it is indexing. It doesn't matter anyway, but you notice that it's a real life example of where you're trying to assess how long it takes. So this is time here. 92, I do believe this is 92 milliseconds, right? Some more examples here is, I think this is actually a continuation. It is indexing time. So you notice a continuation here that we have metrics, specific metrics of how much time it took to index the, can't remember how many documents these were, right? So this would be the index time that we're looking at. And for this particular application that I was using, I have access to different times here. This is the operating system time, and then this is the IR time, right? You notice that the time associated with the OS is somewhat closer to the IR time. But when you're benchmarking, what you pay particular attention to is this, the time it takes for the application itself to perform the operation. All right, so again, just examples of metrics associated with efficiency in this case. And you immediately notice that using this same example here, because we have the time and we have the number of documents we were indexing, we can compute the throughput, because the throughput only takes into account the total number of documents relative to the time it takes, right? So for you to get that number, the threshold, all you do is you identify how many files were being indexed and how long it takes to index the files. And all you do is you get a measure by dividing number of files over the unit time. So you notice that in this case, we get 2.29 as a throughput. So we're saying 2.29 documents per second, right? So when we were running this particular experiment, the throughput of the IR platform is 2.29 documents per second. And using this number, really, you can determine how long it would take to index, let's say, 1,000 or 1,000,000 documents, because you'd know the throughput associated with your IR platform. Right. But again, like I said, typically when you're performing this efficiency measures, when you're benchmarking efficiency of IR platforms, there are a number of confounding factors that you need to take into account. So the structure of documents that you're indexing, right? So the more elements you have, the longer it's going to take, for instance. The computing resources that you have access to, so things like processing power, right? If you have a machine that has 8 CPUs, the indexing will be much faster than a machine that just has 2 CPUs. Already made mention of things like RAM, for instance, right? If you have more RAM, the indexing process will be much faster. Right, so these are all factors that would influence efficiency evaluation, essentially. Another measure that I introduced is the indexing size, the size of the index, because this will dictate how much space will be used, right, by the index. It's computing resources. You're talking about hard disk space here, right? So this example, again, is showing us the total index size. Now, this is 493 documents, and I think these are double encoded documents. No, these are not double encoded documents. These are different types of documents: CSV files, ODS files, PDF files are here as well. So you notice that this indexing these 493 files results in an index that occupies 8.17 megabytes of space, right? This would be an efficiency metric, right? Again, contextualizing yet another metric that I've mentioned, associated with the query itself. This number here that you're looking at in the snapshot here is the latency. So in between you issuing the query and getting back your result, in this particular case, issuing the query von Neumann to the corpus would take 397 milliseconds, right? So this would be latency essentially. And again, similar to the indexing size, we can easily compute the throughput of the query by taking into account the total number of documents that are there, the total number of queries that you can issue at any given point in time relative to how long it takes, right? So you're dividing the number of queries over the time it takes to get the query per unit time, essentially. If you're interested or curious in finding or looking at a real-life example of evaluation, I have a small little section in my master's dissertation where I conducted some basic evaluation of a digital library system, and we benchmarked this design of a digital library system against different corpus sizes. Right, so if you go to that link, you will have access to a description, a very thorough description actually, of an experiment that was designed to do this. Seeing as we've gotten to that stage, let me see if I can locate simple digital, and I think it's this document here. You will find, when you get to that link, you should be able to find the efficiency evaluation in chapter 6 under performance, right? So just to give you a sneak preview here, under performance, you notice that the rigor, systematic nature of evaluation involved us specifying details of the setup process that was used to evaluate the information retrieval platform, right? So the product digital library system actually. So specifics of the hardware that was being used, the test collection that was being used, the structure of the data we're working with. In this case, it was Dublin co-encoded data, the size of the corpus, the number of objects in the corpus. And you notice that when we're evaluating this platform itself, we broke up the corpus into smaller little corpus, right? Trying to ascertain how the IRR platform would behave relative to the increasing size of the collection, right? But keeping other factors consistent, right? And you notice that if you go to chapter 6, you will notice interesting results associated with how long it took to pass or to read the documents themselves, how long the ingestion process was taking. It's quite unfortunate that there's no indexing time here, but these are all examples of efficiency evaluation here, right? A nice graphs also, which is quite nice actually. This was done many years ago, which was 2012, 2013, 2012 I think is when. There we go. So details of the searching and how this was, the results we're getting when the workload was being increased, how long it was taking for us to search through the corpus itself. All right, but the key takeaway point here is that you need to really seriously take into account so-called confounding factors, factors that might affect the overall results of the experiment. Now, if you think about it, this idea of confounding factors, in case people are wondering what these are, is akin to what you typically do when you are designing some simple survey. You know, where you say, oh, we took into account user demographics like age, educational level. All those are things that you anticipate will influence the result, right? And the idea behind incorporating them into your evaluation strategy or your experimental design is you want to prove that once you isolate all these things, this is the sort of result that you get. All right, I'm going to pause here just to find out if people have specific questions with regards to efficiency evaluation before we transition to effectiveness. Is this making sense? Hello?
Yes, we are following, Doc.
Okay. Yeah, well, I don't know if there's a difference between following and this making sense, right? Please, if you want me to explain some parts of what I'm talking about here, let me know, right? Because, yeah, we just want to make sure that this makes sense. Anyway, if there's some parts, there's some portion of what I'm talking about that is not making sense, let's not wait until the end when we have a recap of the section. You can just let me know, and then we can try and see if we can explain further so that it makes sense. But what you will soon see, by the way, is that some of these things will make even more sense. I don't know if you've already discussed this in 5010. Have you looked at evaluation? How you get to evaluate things in 5010 with Dr. Candelo?
So, excuse me, Doc.
Yes.
Excuse
hi.
me, Doc. Yes, Adrian. Yes, I want to find out, like, as you are doing evaluation, what tools do you use to evaluate these library information systems or databases? What do we use to evaluate? Like, do we compare?
What
get
tools you mean?
Yeah, how do we? In other way, I'm trying to find out how do we evaluate these systems? Okay, practically, do we go into open them, check, or maybe there are tools that can evaluate them from outside, or what really happens?
Yeah, so that's an interesting question. And the answer I have for you is it depends on what you're evaluating. Now, here's something I was leaving to the end. For the most part, the evaluation that you tend to do is not efficiency evaluation per se, but you're going to focus more on the effectiveness evaluation. So it depends on what you're evaluating. For efficiency, it can be as simple as just putting together scripts, right? Because it's rarely the case that you would design an IR platform from scratch. You would, in fact, what you find yourself doing is, let's say let's just hypothetically speaking, let's say you wanted to evaluate Koha, for instance, the searching in Koha. What you're doing is you're not evaluating Koha per se, but you're evaluating the search platform incorporated with Koha. Now, I don't know what Koha, what search platform is in Koha search platform. I don't know what search platform this uses, but maybe it's a search engine. If it's I can't find this. I wanted to use something that people are kind of used to here. I'll have to look this up. But DSpace is integrated with Apache Solr. So if you wanted to evaluate the efficiency of searching in a DSpace repository, for instance, what you'd be doing is evaluating Apache Solr. So a scenario where you'd find yourself doing that is if you're wanting to decide whether you want to use Apache Solr or an alternative search platform. There are a lot out there. So for instance, Lucene, right, is an example. Elasticsearch is another example, right? So if you are sitting there, you're at work and you've been told part of what we need to do is let's find a search platform that is more efficient. What you would be doing is performing efficiency evaluations against those different search platforms. So if you go to search engine platforms, Wikipedia, what you'll notice, right, is there is a list of open source search engine platforms. Apache Solr is not the only one, right? Apache Solr is not the only one. Apache Solr. Let me see if I'll click Apache Solr and then I'll go to others. Other link here, let's see if there's list of common information retrieval libraries. And this is horrible, it's just one. So, and I was hoping there was a good enough comparison. Usually there is a nice metric that you typically have. This is bad. Anyway, so what you'll be doing is evaluating Apache Solr against Manatee, against Sphinx, against, I've never used Zapier. I have no idea what this is, but I've played around with Sphinx. Elasticsearch, you notice both Apache Solr and Elasticsearch are built on top of the Lucene library, right? So a scenario where you'd be conducting this evaluation is comparing these different search platforms. Because in fact, with this space, you can replace Apache Solr with any one of these. It's easy. Because what this space does is it makes reference to an API associated with Apache Solr, right? In terms of tools, Adrian, for efficiency, it's not really like the predefined tools that you use. You'd have to come up with so-called scripts on your own. So you just, as part of your experimental design, you design or you implement scripts that will automate the whole process. So again, if you access the link associated with my master's dissertation, there's an explanation where I get to explain how this was done, I think. Oh, sorry, not here, but in here. Scripts were implemented to do all of these things, right? So to automatically benchmark against the different workloads that we had. I hope that kind of answers your question. Maybe, maybe not.
Yes, Doc, it has.
Okay. Okay, great. Thanks. All right. So I don't know if there are any questions to do with efficiency before we transition to effectiveness. Right. Right. So again, just to reiterate some of the fundamental differences between effectiveness and efficiency. Usually, in almost all instances, effectiveness is user-centered, so it involves subjective measures. It involves human subjects, not subjects. They say now it's participants, right? So it's human participants. They used to be called subjects back in the day. I don't know if Kando has mentioned this. So you are dealing with human participants, right? It's a subjective measure. And what you're doing is to find out the extent towards which the IR platform satisfies a particular user need, right? So you're measuring this relative to what a user is wanting to extract out of the IR platform when they're searching.
Sorry, Doc, Judith would like to join. She's been pending just in case.
Yeah, I haven't, is she in the correct, is she using the correct, let me check. Is she using the correct, correct meeting link? I haven't seen her request. I'll go to the, can you have her go to the,
let me resend her the link again.
okay. Use the following meeting details. Yeah. Oh, wow. I didn't know there was copy join information. Oh, it's just a link this time around. Okay. That should suffice anyway. We'll let her in once she comes through. All right. Are there any? Yeah, but she hasn't. I can't see her request. And right. Okay. I wonder what email address she uses. Idea when you're using Gmail and you get that request, you automatically let in, which is why. But with those of you that are using like Yahoo and whatnot, external email accounts are the ones that have to be explicitly let in. But anyways, we'll wait to see if we can see her request. Right. So in terms of the effectiveness, like I was saying, typically user-centered. And some common traditional metrics that are used to measure effectiveness when you get back results as you're searching things like recall and precision, for instance, right? And we'll explain a bit more about these things by referring to specific examples, but recall just looks at the total number of relevant results that are returned. So if you issue a query and you have, let's say, 100 or 1,000 results that are returned, the idea behind recall is you're trying to find out of the 1,000 results, how many of them are relevant. So based on the user feedback that you get, on average, how many of the 1,000 results would be relevant? And then precision would be a measure that looks at the returned results relative to the corpus itself. Sorry, it's the other way around. So the recall would be relative to the corpus, and then the precision would be relative to what is returned. So again, for the recall, you're looking at out of what is returned, how many of these results are relevant compared with the overall number of relevant things in the corpus. Then the precision will be looking at the results returned, how many are relevant relative to what has been returned back. Look at an example just now. So yeah, so recall whether a particular item has been returned here. Yeah, so with the recall, you're looking at really whether the extent towards which the IR system will retrieve documents that are relevant to the user's information need. It's typically obvious, it makes sense that this is influenced by the query, right? Because whether or not something is relevant to your information need will be dependent on whether the query that you're issuing to the IR platform is closer to what has been indexed by the IR platform. And this makes sense because this explains why the query has to be controlled when you're evaluating the IR platform, for instance. So as an example here, we're saying the recall, right, can be expressed using a formula where you're taking into account the total number of relevant results that are returned over the total number of relevant items in the corpus, in the entire collection. And because this is a fraction, obviously multiplied by 100, and then the recall is expressed as a percentage. So a number like 20%, for instance, against 30% will mean that the result with a higher value signals that you have a higher recall. Right? As an example here, using the user institution repository here, assuming you have a total of 100 documents that are relevant to the query information retrieval, but only 70 are returned. And assuming that collection, that corpus has 100 documents here, what we're saying is that the recall is going to be equal to the total number of things returned that are relevant, which are 70, over the total number of relevant items in the collection, which are 100. So it would be like 70 over 100 times 100, which is obviously going to be 70%. Just a simple example to explain how recall is evaluated. Precision, on the other hand, obviously you're measuring how precise the IR is, but it's relative to what is returned. Recall is relative to what is in the corpus, right? So in this example, we're saying in this particular case for precision, we're saying can be represented by a mathematical expression which takes into account the total number of relevant items returned over all the items that have been returned once you issue the query. Right, so again here, this is supposed to be precision, not recall, by the way. Precision is influenced by the queries that are issued by the user, and this makes sense similar to recall. So in this example, we're saying if you issue the same query information retrieval in the UNZA IR, and what you return back are 100 documents, but out of the 100 documents, only 40 of those are relevant, the precision is going to be equal to the number of relevant documents over the total number of documents returned once you issue the information retrieval query times 100, so that you get the 40%. Right? And then it turns out that there's a metric that takes into account these two measures, the precision and the recall. It's called the harmonic mean, and this is how it's expressed. And the idea behind the harmonic mean is it gives you a metric that takes into account both of these different things, the recall and the precision. And finally, she has requested, oh, it's Harriet, not Judith. Oh, Judith is in, okay. I didn't see her coming, okay. All right. So the F score or the F measure is nothing more than the harmonic mean, and it's expressed using this formula here. You multiply the precision and the recall, and then multiply by 2, and then you divide it by the sum of the precision and the recall. And in some instances, if you want to be fancy, you can come up with graphical representations to showcase how the behavior of the harmonic mean as you're getting different values of the precision and the recall. A nice visual representation that you'll find on Wikipedia, I've found this useful to explain precision and recall. People tend to have a hard time distinguishing between precision and recall. Remember, we are saying precision is relative to what is extracted. Recall is relative to what is in the corpus. Right? So I hope this makes sense. So if you look at this, right, as being your corpus, this entire thing here where you have false negatives, true positives, and false positives, you're saying that if you look at this space here, this space as being your corpus, what is retained is this circle here. What is retained will have relevant things and things that are irrelevant. So we're saying precision is going to be equal to the relevant things retained, which is this green slice here, over everything that is retained, the green plus the red, which is why you have this circle here, green and red. Recall, on the other hand, is going to be equal to the things that are retained that are relevant, the green in the circle, over everything in the corpus, which is relevant, right? Which is everything in here. The false negatives plus the true positives here. So which is why we have this slice here that includes everything that is in the corpus that wasn't returned and everything that was returned as well. All right, but it turns out that, but really, in terms of effectiveness, it's not just these traditional measures or markers like precision, recall, and the harmonic mean, F1 score, F1 measure that are taken into account. There are other obscure metrics that you can take into account. So strange things like satisfaction. Are users satisfied once they are using the IR platform? The beauty with information retrieval is it's a field that has been around for decades, right? And it's been perfected. They are predefined measurement instruments that you can use for these things. So you do not have to craft or think of which matrix am I going to use. They're predefined matrix, right? So you can measure the satisfaction. To what extent are you satisfied with the results that are returned by this IR platform? Are you satisfied? You ask, are you satisfied? Strongly agree, neutral, strongly disagree, or disagree, strongly disagree, right? So satisfaction. But the bottom line really is that the metrics associated with effectiveness are subjective measures because you are involving human beings, because the responses that you get back will be different. Our worldview is different. The way we process information is different. All right, so you can also measure things like the user experience here, where you take into account users' emotions, and really when you're taking into account things like user experiences here, you're taking into account metrics that are commonly used in so-called human-computer interaction. They're again predefined measurement instruments where you measure things like user experience can be measured actually, right? So user experience, ease of use, or about UX or about UX. If you're interested in familiarizing yourself with measures that will take into account like emotions and whatnot. I do encourage you to, at your own time, just go to all about UX. UX is a user experience. You have interesting measures that are typically taken into account when you're measuring the user experience of the user. But the bottom line is that all of these things here are subjective measures, right? So other things that you can take into account is usability of the, I guess, the interface of the information retrieval platforms here. Again, satisfaction is coming up here. But again, similar to efficiency, what you want to do when you're measuring effectiveness is take into account all potential confounding factors. Queries that are being used. Because you're dealing with human beings, participants, you want to collect or solicit or elicit demographic details, age. The query that my father will be able to construct to issue a Google, to issue a query on Google would probably be out of this world, because the experience that he has, he doesn't have that much experience with search engines, right? He doesn't search for information as often as people in our age group, for instance, right? So maybe a demographic details you might want to capture is things like the age. That's not the age, but maybe the experience searching. You ask the user, how long, what sort of experience do you have working with search engines or searching on Google, right? And you have fixed responses like less than 1 year, more than 5 years, more than 10 years, right? Those are all important things that will collectively account towards what we're calling confounding factors. And you want control for those things. So competence levels, right? So these are all subjective things, but you ask users, to what extent do you think you are competent in using a search engine, right? And a lot of things here. If you're interested in looking at a classic study that is associated with effectiveness, there's this study from the University of Cape Town. I was not involved per se, but I just came across it because it happened to have been done in that lab that I discussed or highlighted when we're looking at research that is being done by other labs. So if you go here, the students explain how they go to construct a study that was centered around evaluating the effectiveness. And what you immediately realize is that these people get to explain that they used predefined queries, four queries. So they had to construct queries for the users rather than leave it up to the user to construct the queries. They highlight things like, oh, we used 24 participants, right? This is important if you want to ascertain the statistical significance of the results that you're getting back, right? These are important things that you have to take into account, and they're making mention of the fact that they were interested in measuring relevance judgments of just the top 10 results that you get back. So whatever search platform they were working with here, they were interested in top 10 results that are being returned. So you have a search query where you are searching for information retrieval. You know that your typical search information retrieval in Africa, the search platform will typically return multiple pages. So what these people are saying is that they were restricting the results to just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So just 10 results and not 1,000 results or 100 results. These are important things to take into account. All right. Last year, the group that I worked with that we're working towards comparing, I don't know if you remember this study, I explained it when we were looking at digital libraries. They were, at some point, they had a baseline repository that did not incorporate a controlled vocabulary set, and another repository that had incorporated controlled vocabularies. So the idea was, would users be able to get more relevant results if you search through a repository that has been integrated with a controlled vocabulary set versus a repository that has not been incorporated with a controlled vocabulary set, right? These are important things that you take into account here. All right, so I mean, that wraps up I guess, this idea of evaluation really, we focused on two key evaluation aspects, so efficiency versus evaluation, and we did highlight the fact that effectiveness would typically be subjective because you're dealing with human participants. Efficiency is objective because you're literally dealing with a machine here, right? You're interested in measurables that are typically associated with computing resources. And we also pointed or looked at specific metrics that are used, things that you're actually measuring: precision, recall, satisfaction, indexing time, query time, right? Throughput. I hope this makes sense. I thought maybe we can pause for now. I'll pause and see if there are questions, and then we can see if tomorrow after Abel's talk, we can do a walkthrough of Apache Solr to just try and see how these information retrieval platforms kind of work and what sort of metrics we can extract as we're indexing content, as we're searching through the content. Are there any questions? Okay, I don't know what is so quiet on the Western Front. I don't know what to say. Easy, but okay. If there are no questions, then it's making sense, and we are following. That's good. Although here's the thing, right? That it's making sense and we are following. That's a subjective measure, right? Only one participant has. If we were conducting a study here to find out if module number 7 is making sense, then we would have to conduct a survey, right? We ask you to say, respond, to what extent is this making sense? Open-ended questions, and then you respond in the chat. Then based on the responses that are getting back, we get the average, right? So an example of like a subjective measure here. Throughput is nothing more than you're measuring something relative to a unit time. You can think of it, a simple example I have is, if I was to ask you what your throughput is in relation to the speed when you walk from home to campus, what you do is you take into account the distance from where you stay to campus divided by the time. The throughput associated when we walk to campus versus when you cycle to campus versus when you drive to campus would be different. So throughput is nothing more than just a measure relative to, it could be anything, it's relative to a unit time. So throughput associated with the queries, the number of queries that are processed in a given unit time. And the unit time is usually fixed, it's usually per second, right? How many documents you can index per second? It's a fraction of an entity per unit time, or a measurable per unit time. I hope that that explains. Yeah, the idea of record precision, sure, using the graph, we'll go back here in this chart. So the idea behind precision and recall is we are saying, when you are measuring the precision, you are looking at the things, when you issue a query, the things that are relevant when you get back the results. How many of the results are relevant relative to everything that is returned? Observe, we're still on the graph. I issue this query, right? Information retrieval in Africa. The things that are returned here, 61,100,000 results. Now, it wouldn't be practical for us to conduct an experiment where we measure the efficiency and precision, because we would have to have human subjects go through all the 61 million documents. But observe, what we're saying is, out of these 61.1 million results, how many of them are relevant relative to this query? Right, so you just count how many of them, but you'd have users tell you to say, this is relevant, this is relevant, this is not relevant. So you count how many of these 61 million are relevant, right? And then you divide the ones that are relevant over everything that is returned. So if out of the 61 million records, only let's say 100,000 are relevant, the precision will be 100,000 divided by 61,100,000 times 100. That would be your precision. The recall, on the other hand, would take into account those that are relevant out of what is returned. Filter out everything that is relevant relative to everything in the corpus. In this case, it's the index that is relevant. So forget this 61.1 million results. Assuming that for the Google, documents that are associated with information retrieval in Africa, let's say 100 million, then you're no longer looking at this 61,100,000 documents, but you're looking at the 100 million records that have information related to this query. So you divide the 100,000 records that are relevant over everything, all the documents in that corpus that are relevant. So you notice that in both instances where you're dealing with precision and recall, the upper part is the same, relevant results. The only thing that is different is the bottom part. For precision, you're looking at everything that is returned. For recall, you're looking at everything that is relevant, that is in the corpus. I hope that makes sense. I think it's Mizul was asking for clarity. Okay, I guess it's all quiet on the Western Front. I'll pause for now. We'll continue this interaction tomorrow, where we will try and see if immediately after Abel's talk, we'll play around with Apache Solar. I don't want us to waste time installing Apache Solar, but I can quickly do a demo of how to install this. It's not that hard, it turns out. And then we can play around with Apache Solar to see how we go about indexing documents. So we'll index a corpus and then see exactly what happens behind the scene. Okay, so if there are no questions or comments or concerns, then I guess we'll call it a night, and then I'll see you tomorrow. Please remember that our interaction begins at 17 hours, beginning with Abel's talk tomorrow.
Perfect.
Okay, thank you. So thanks and good night. If you're going to sleep, but Oh, by the way, I was asking questions. Have you started looking at how you get to? Because when you discuss study designs, right? When you discuss study designs, one of the things that you get to mention is things to do with evaluation. In 5010, have you done this? Have you done this in 5010?
Come again, Doctor, question.
Have you discussed experimental design or study designs in 5010, the research methods course?
Not yet.
No, okay, I'm sure this thing will make sense once you do that then. I hope you're going to discuss this very soon. Because it turns out it's important, right? If you look at the UNZA repository, right? And I know I said good night, but I guess this is important now. But if we go to the UNZA repository and you just start going through theses and dissertations that people have done in the past, the title speaks volumes of what's going on, right? It speaks a lot about what's going on. Observe. Adherence. Okay, this is a bad example, but experiences and expectations. And a big one, everyone likes, oh, I'm evaluating the effectiveness of, this is what Dokoe, what not, they're going to measure effectiveness. What metric are you going to use? What specific measurables are you using, right? Effect of something, impact, right? So it turns out that once you discuss all these things with Dr. Kandelwa, you will, I guess, understand this a lot more actually. One of the things you will do once you conduct the studies, you need to evaluate it anyway to a certain extent. You need to measure what you're doing, right? Evaluation of water use, efficiency, right? So this tells you that this person was using specific metrics to measure the efficiency of water use, right? But anyways, hopefully this thing will make sense once we discuss this in 5010 with Dr. Kandalwa. We'll call it a night. Thanks a lot, and till we meet again, which is tomorrow at 17 hours. Thank you and good night.
Good night.